Here we have the function w is equal to the square root of x squared plus y squared. Now, you have a function x, the function x, right? The same x here is itself a function. It's 3 cos t, and then y now is a function 3 sin t. You need to find the partial derivative of w with respect to t. Now, of course, you remember, you could find delta w by delta x here. You could also find delta w by delta y. You can find delta x by delta t. You can find delta y by delta t. Thing is, how do you get delta w by delta t? Well, remember that delta w by delta t is equal to, you're going to set this up so that if you cancel the various deltas that you have, various partial derivatives that you have, you will end up with delta w by delta t remaining, right? So you're going to have delta w by delta something. What would it be? Okay, suppose you have delta w by delta x. Delta w by delta x. Remember, you can also find delta x by delta t. So you find the partial of x by partial of t. Well, in this case, it wouldn't be partial because it's only x and t you have as a variable. So you could say this is dx by dt. Alright? D means the total derivative. There's only x and t. In this case, it has to be partial because you have 3 variables and you're going to treat one of them as if it's a constant. You temporarily do that. So this would be partial. Alright, so this one, partial of w with respect to x times derivative of x with respect to t. Okay? Now notice delta would cancel, the derivatives here would cancel, leaving delta w by dt. Alright, so here now we have the partial of w with respect to y times, well, it should be dy by dt. So you could cancel these. Oh, yeah, you could cancel these, and you have the w, delta w, or the partial derivative of w with respect to t, and delta w by delta t. So you set it up like that. Alright? Now, here is really total derivatives that you're finding here. So to be consistent throughout, you could still write these as partial, as delta instead of d, so that you end up with a delta t. But anyway, what is the partial derivative of w with respect to x? You have to work that one out, right? Now, partial of w with respect to x. You would have to use the chain rule, differentiation by substitution. Now, if you've been practicing the chain rule a lot, you could do it the shortcut way. But let me assume you haven't been practicing it a lot or in recent times. So let's do it the long way with all the steps. You have w is equal to the square root of x squared plus y squared. Okay? Now, let u be equal to x squared plus y squared. Alright. Then what you're going to have is that the partial, well, in this case it will just be u, so let's use d for this. dw by, oh yeah, it's partial, we have it originally as partial, so let's use d, let's use delta. Partial w by partial x is equal to, well, in this case it's going to be partial w by partial u times partial u by partial x. Now here you could get partial u by partial x from that. Now the partial of u by partial x, let me write it on there. Partial u by partial x would be, in this case it would be just be 2x. Okay? Now you want partial w by partial u. When you write u equal this, it means w is the square root of u. Right? Well, you need to write it in a way that you can differentiate it. So write it as u raised to the power of a half. See that? So w is equal to u to the half. Now what is partial w? The derivative of w with respect to u. In this case, remember you multiply by the power times u to the, and then you reduce the old power by 1 to get the new power, minus 1 from the old power to get the new power. So you have half u to the negative half. See that? So therefore, delta w by delta x is equal to, now remember it's derivative of w with respect to u. In this case, half u to the negative half times derivative of u with respect to x, which is 2x. But the thing now is, you need to change the u back to what it was. U was square root of x squared. No, u was x squared plus y squared. So this is half x squared plus y squared to the negative half times 2x. You can simplify this. 2 times a half is 1, so it's all gone. Let's write it exactly as it is up here. X squared plus y squared to the negative half times x. So delta w by delta x, delta w by delta x is equal to x squared plus y squared to the negative half, x squared plus y squared to the negative half. You could write it with the square root sign and so on, but we'll do that shortly. Let me draw a line here to separate what was done on the right hand side. No, that is delta u w by delta x. What about delta? Oh, this should be plus, you know. I wrote minus here. Yeah. What about delta w by delta y? Delta w by delta y equal. Now, if you work it out, you'll do the same thing with the y as you did with the x. Well, let's try and deal with this mentally now. Delta w by delta y. doing it mentally. You have the inside function, which we would call u, and we will do the u by dy. That is the derivative of the inside function. What you get for the inside derivative of the inside function, the x squared plus y squared, and you differentiate that with respect to y, it will be 2y. So when you differentiate the inside function, you get 2y times what now? This is the outside function. It's all of this thing here to the power of a half. And then you say half times this to the power of half minus 1. So it's half times all of that to the negative half. It's going to be half times x squared plus y squared to the negative half. And then you see that this becomes half by 2 is 1. So it's y x squared plus y squared to the negative half. So what happens with the x here? It happens with the y as well. You see that? So for the first one, we did it step by step, showing all the steps, but for the second one, we do it mentally. Alright. You need delta x by delta t now. So partial x by partial t would be what? Well, when you differentiate cos, you get negative sine. So partial x by partial t would be negative 3 sine t. So it's negative 3 sine t. And then what else was it? Partial y by partial t. Was that so? Right, partial y by partial t. When you differentiate sine, you get cos. So this will become 3 cos t. Okay, good. So you have that. So we can put everything together now. Partial w by partial t equal partial w by partial t equal. Let's write back this as it is. Partial w by partial x by partial t, partial w by partial x times partial x by partial t plus partial w by partial y by partial t, partial w by partial y times partial y by partial t. Now, what were these things again? Partial w by partial x was, now let's write this without the raised to the power. Now here you have x times something. So partial w by partial t is equal to x times. Now remember that from your knowledge of indices, when you raise a number to a fraction, the denominator of the fraction shows the root. In this case, when you raise a number to the half, it means the square root of. And the thing is, also, you have to remember, when you raise a number, any function, to a negative power, it's same as 1 over the function to the positive power. So this is going to be 1 over the square root of x squared plus y squared. So we can write it as times 1 over the square root of x squared plus y squared. But then you might as well just write it as x over square root of x squared plus y squared. X over the square root of x squared plus y squared times, alright, partial x by partial t. What was partial x by partial t again? So it's negative 3 sine t. You can just put the negative in front of here. 3 sine t. Well, you know what? We could just put the 3 sine t right up against the x, you know. Could even write it as 3x sine t. Right? Nice. It's negative 3x sine t. Right? And then you say plus. Alright, so plus what now? You have partial w by partial y. Partial w by partial y. This is going to be y times 1 over the square root of x squared plus y squared. What will happen to this is the same thing that happened to this up here, the x. So it's going to be y over the square root of x squared plus y squared. It's going to be y over the square root of x squared plus y squared. Now, this now, the delta y by delta t is 3 cos t. So you can just put the 3y cos t here. Now, of course, you can do two things here now. For delta w by delta t, what you can do, this put it first because it's positive. 3y cos t over the square root of x squared plus y squared minus 3x cos t over the square root of x squared plus y squared. What you could do now, you could make this a little more compact. Delta w by delta t equal. You remember, when you have something over a number as a fraction, plus or minus something over the same number, you just put them together and put them over the number. So this is 3y cos t minus 3x cos t over 1 square root of x squared plus y squared. Alright. You could even factorize this, you know. Wait, hold on. Where did I get 2 cos t from? The first one is, this one is sine. I rewrote this, what? My. It should be sine, not cos. Right, this should be sine 2. Alright. So you could even factor out the 3. Suppose you do that. This 3 would no longer be there. And you would have this. Right? So in the bracket you have y cos t minus x sin t. So this is 3 times that over square root of x squared plus y squared.